So today we're going to be looking at entertainment expenses and standard deviation. Now, I know this looks like a lot, looks like it's like 7 pages. Most of it's words. It's not a lot of actual math. It's just that these are applied problems, so they look a little longer. So as a warm-up, we're just going to look at some different problems. So given the problem set of expenses, so we have something for $7, something for $16.50, something for $12, something for $6.50, and something for $10. First, it says to find the difference between the greatest and the least expense. So looks like the greatest is $16.50, so we'll put $sign $16.50. The difference is subtraction. Looks like the least is $7 minus this $7. If you subtract the two, we're going to get $9.50. Okay. Next, it says to find the mean, so the average of the greatest and the least expense. So if we add this $16.50 plus this $7, and we're going to divide it by 2 because there's 2 of them, we're going to get, since this is money, $11.75. We're going to make sure it's a decimal instead of a fraction. And anytime you have a decimal, you can just go 2 places past the decimal point. And then it says to find the mean of the entire data set. So we'll add them all together. So 7 plus this $16.50. See if I can write what I'm saying. Plus this $12, plus this $6.50, plus this $10. Divided by, there are 1, 2, 3, 4, 5 of them. That is going to get you $10.40 on average for these expenses. So, reading the next part. As a teenager, entertainment expenses might comprise a large fraction of your discretionary expenses. There can be quite a range of prices when it comes to these expenses. However, buying a song on iTunes can cost less than $1, while admission to a sporting event or concert for a family can cost several $100s. Consumers usually need to prioritize and make choices to keep within their budget, since entertainment expenses can vary greatly, and they're always discretionary because they're not necessary. Measures of dispersion, also referred to as spread, or how spread out data parts are single numbers that are used to represent a range of numbers in a given data set. So if you have a set of numbers, you can represent this or talk about this using the dispersion, or talking about how spread out the numbers actually are. The mean, median, and mode don't really tell the whole story of the distribution. A frequency distribution, which is the charts that we've been looking at, which has each piece of data on it, does include how spread out the scores are because it has every piece of data, but it's sometimes difficult to interpret the dispersion from a table since it has so many entries because it has everything in it. There are several single statistics that summarize the dispersion of a distribution of data. So there's a bunch of different things we can look at in order to talk about dispersion. Knowing the dispersion of the data, or how spread out a data set is, helps you to describe it and look for patterns in how you spend your discretionary income. So looking at example 1, Mrs. Smith's video club has 10 students in it. On the first day the club met, she asked the members how many movies they streamed last year. I don't know how they counted, but they did. The 10 students reported these numbers. Okay, so we got the numbers here. Draw a little curly brackets around it, show it's a data set. What's the difference between the highest and lowest numbers? All right, highest number, 32 looks like it, but then we get over here and it's 41. Okay, so the difference is subtraction. Okay, the lowest looks like it's 9. 41 minus 9 gives you 32. Okay, that's called the range. So now we've went over mean, median, mode, and range. So range is never negative, and it can only be 0 if all of the numbers are the same. Okay, so the highest and the lowest, you just take them and subtract the lowest from the highest to find the range. So practice problem number 1, find the range for the following data set. You can do that on your own. Take the highest, subtract the lowest. So do that one on your own. Example 2, Maria, a video production club member, noticed the range seemed to ignore all numbers. It doesn't pay attention to any numbers except for the highest and the lowest. So she thought that maybe a better measure of how spread out the data would be, or the dispersion of the data set, would be to take an average of how far each number is from the mean. So we would take the mean, or take each number and subtract the mean. How far on average is each entry in the data set from example 1 from the mean of distribution? So we'll fill in this data set. So if we take the numbers from up here, so if we take each of these, I've got them written down over here, we can write them in each xi, so that's just each data point here. So anytime you have xi, it's just the first value, the second value, the numbers it gives you. So 32, 18, 15, 27, 24, 22, 9, 41, 16, and 26. Okay, so we know what xi is. That's just taking that number, and we're subtracting x bar. X bar is the mean, so the average. So if we need the average of these, we're going to take 32 plus 18 plus 15 plus 27 plus all these added together. Okay, and we're going to divide by however many numbers we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we do all this added together and divide it by 10, we're going to get the mean is 23. Okay, so for each of these, we're going to take xi, so the number, and subtract the mean. Okay, so 32 minus 23 gives you 9. This is 18, subtract 23, negative 5. We take the number, 15, subtract the mean, 23. That's going to give you negative 8. 27 minus 23 gives you 4. Okay, 24 minus 23, because that is the mean again, that's a 2, sorry, gives you negative 1, or sorry, positive 1. 22 minus 23 gives you negative 1. And I want you to go ahead and fill in the rest of those. Okay? So that's how you do. You just take each number and you subtract it from the mean. Or subtract the mean from it. So the distance between each number and its mean is going to be called the deviation, because that's how far it deviates from the mean. The average of how far each number is from the mean, so if we average all these numbers together, it's called the mean deviation. So actually, I will actually go through and do all of these. Okay, so if we go back, we do 9 minus 23 gives us negative 14, 41 minus 23, 16 minus 23, we're just taking this number over here, 26 minus 23. We simplify all those, we get 18, negative 7, and 3. Okay, so now in this next part, in order to find the average for all these, we're just going to add all of these together. Okay, plus all of these. 4 plus 1 plus negative 1 plus negative 14 plus 18 plus negative 7 plus 3. And then we're going to divide by 10 because we have 10 numbers. So this average here would give us 9 plus, let me write this in a calculator, I didn't have this one out. 4 plus 1 plus negative 1 plus negative 14 plus 18 plus negative 7 plus 3. It's going to give you 0. Okay? So we can actually fill it in, and if the mean deviation uses a sum, since the mean deviation uses a sum, since you're adding all these things together, it can be represented algebraically using the summation. So using sigma. So the mean deviation, see if I can write, mean deviation is going to be the sum. You sum them all together for each number. You're going to take that number, so xi minus x bar. So again, x bar is the mean, so we are going to add together each number minus the mean for each number. So we're going to take that number, subtract it, and then we're going to divide it by n. Okay? So last time we got 0. So practice problem 2. Let's look at it. So we know that x bar is what we need first. So we have 8 plus 12 plus 34 plus 55 plus 68. This one's a little easier because it is only 5 numbers divided by 5. you're going to get 35.4. Okay? So x bar is 35.4. So if we're doing each number, so xi minus x bar, so x1 minus x bar, x2 minus x bar, that's all that means. Okay? And then we have to do it for all 5 numbers, so 1 through 5. So each one's going to be labeled x1, x2, x3, x4, x5. You're just taking each number. So x1 is 8 minus x bar is 35.4. Okay? x2 is 12 minus x bar is the mean, 35.4. x3 is 34 minus 35.4. That's the mean. Okay? x4 is 55 minus 35.4 minus the mean again. And then lastly, we have 68 is the last number, minus this 35.4. Okay, if we simplify these, we get negative 27.4, negative 23.4, negative 1.4, 19.6, and 32.6. Okay, and then we know that the mean deviation, as we've got written up here, is going to be the sum. Okay, so from I is 1 to n, okay, of xi minus x bar. So that's all of these added together, divided by n. If you've written this down, okay? So I just copied this right there, okay? So if we add all these together, that's what that means. We have negative 27.4 plus negative 23.4 plus negative 1.4 plus 19.6 plus 32.6. So that means you take xi minus x bar. So I did it for each number. That's what that means. And we add them together. Okay, so I've got that. And then divided by n is the number of numbers you have. You have 1, 2, 3, 4, 5. But that's going to be 0 divided by 5, which is still going to give us 0. So the absolute value of a number is its positive distance from 0. Okay? The mean absolute deviation is a statistic that takes the absolute value of each number's deviation. So we're going to do it just like we did this time, except instead of having these negatives, we're going to make them all positive so that we don't end up getting 0 every time. They don't cancel each other out. So if we look at practice problem number 3, we're going to do it just like we did just now, except we're going to make them positive. So when we did x1 minus x bar, we need to make it positive. We got 27.4 because it was negative 27.4. We're going to do the same thing for each of these. We're going to make them positive. We're just going to take the answer from the last page and we're going to make it positive. Okay, so we have 23.4. Oops, 23.4, 1.4. We're just making these positive is all that means. The bars stand for, on either side, stand for the absolute value. That's all we're doing. So now, the mean absolute, so the word absolute means you're taking the absolute value, deviation, is going to be all of these added together. Divided by 5 still. And that's going to give us 20.88. Okay, so it doesn't cancel each other out to get to 0 because we made them all positive. So the mean absolute deviation requires the use of absolute value, which is kind of cumbersome or difficult for mathematicians to make calculations with. So we're not often using it as a measure of dispersion in statistics. The negative and positive cancellation or deviations used to compute the mean deviation, they actually canceled each other out. So we got 0 every time. So to eliminate these problems, we statisticians or mathematicians who work with statistics square each deviation from the mean. So they take these the number minus the mean, and then we're just squaring it, putting a little 2 on the top, multiplying it by itself. Okay? Each deviation from the mean, and we're finding the average of these instead. So this is going to be called the variance. of the numbers. The variance, which we denote as this little sigma squared, you can draw it like that, okay? Small sigma squared, can be shown algebraically. So if we're looking for this sigma squared, we're going to be adding together for each number. We're going to take the number, subtract the mean still, and we're going to square that answer, okay? And then at the end, after we add all those together, we're going to divide by the number of data points. So we're going to add each number minus the mean squared. So we're going to do that for each number. We're going to add them together. And then we're going to divide by the number of data points. It's the number of numbers that you're given in the data. So the variance is a very commonly used measure of dispersion. We use that a lot. Okay? So example 3 says to find the variance for the data on the video production class from example 1. So if I go ahead and fill in these numbers, we have 32, 18, 15, 27, 24, 22, 9, 41, 16, 26, and then if we add them all to a total, I didn't write this in there, sorry, we get 230 altogether. So that's how many numbers they've streamed. We did find the mean. So we discovered that the mean, this x bar, we figured out on number 1. The mean is 23. Okay, so x bar is 23. Okay, so we're taking this number, 32 minus 23. Okay, so that's for the first one. Then we do 18 minus 23. Okay, we do that for each number. We just take the number and subtract 23 to get this one. Okay, 18, negative 7, 3, and 0. Okay, but then we're going to take that number, okay, and we're going to square it. We're going to say 9 squared gives us 81. Negative 5 squared gives us 25. Negative 8 squared. Okay, so negative 8 squared gives us 64. 4 squared is 16. We're just squaring this number. 1 squared is 1. Negative 1 squared is also 1, because negative 1 times negative 1, which gives us 1. Negative 14 squared, if you need, you can type these in a calculator, gives you 196. 18 squared is 324. Negative 7 squared is 49. 3 squared is 9. And then if we add all these together, we're going to get 766. Okay? So the problem was, if we kept these negative signs, then we end up with 0 because they cancel each other out. The absolute value is hard to work with, so instead we squared these numbers and added them together. So if we're looking for sigma squared, we're going to add together all these xi minus x bar squareds. So we're going to add all these together, which we did here, and we're just going to divide by the number we have. So we added them all together here already, so we got 766. So for each number, we took that number, we subtracted the mean, and then whatever our answer was, we squared it. Okay, we added all those together, got 766, and then here we have 10 numbers. So if I do 66 divided by 10, you get 76.6. That's all you got to do. So looking at another practice problem, cell phones have changed from a discretionary expense to an essential expense over the past 2 decades. So in the past 20 years, they've changed from something you didn't really have to have, but definitely now it's something you really should have, most likely. The following data set shows the number of new cell phones owned by students at Cold Spring High School during the first 5 months of the school year. Find the variance for this data set. So we're looking for sigma squared. Round to the nearest hundredth. Use the chart, but like before. So on the xi, that's just each data point. So each of these numbers. So we have 11, 13, 15, 28, and 30. And then again, we're going to do the total down here. So if we add all these together, we get 97. Okay, now we're going to find the mean first. So x bar is going to be all these numbers added together. Okay, and then divided by 5, because there's 5 numbers. We're going to get 19.4. Okay, so xi minus x bar is going to be 11. So the number minus the mean. So 11 minus 19.4, like this. Okay, that's going to give us negative 8.4. 13 minus 19.4, we're just going to do that for all of them. Okay, I'm not going to write them all out, but that's what we're doing. We're taking the number over here and subtracting the mean. It's going to give us negative 6.4, negative 4.4, 8.6, and 10.6. And if we add all these together, we're going to get 0 because of the negative signs canceling out with the positive signs. Okay, so because, again, we don't want to just take the absolute value, we're going to square each number. So negative 8.4 squared is 70.56. Negative 6.4 squared is 40.96. Negative 4.4 squared is 19.36. We have 73.96 for 8.6 squared. And if we square 10.6, it's 112.36. You can type those in a calculator. Okay, and then if we add them all together, we get 317.20. Okay, so this is what we need. Sigma squared is going to be the sum of all of these numbers, where we took each number, we subtracted the mean, and we squared it. So each of these numbers, if we add them all together, that's what we get. We get this 317.20. That's what that's asking. We did this for each number, and we added them all together. And then we're divided by the number we have. So we have 1, 2, 3, 4, 5 numbers here. And if we calculate that, we get 63.44. So that's going to be the variance. Since the variance squares the deviations from the mean, the units of the variance also have to be squared. So if a problem's original units are in hours, so it's asking you how many hours you've watched of something, the units of the variance are going to be hours squared. Doesn't make sense. If the units are movies, like in this example from earlier, how many movies have you watched? The units of the variance are going to be, is going to be movies squared. And if the units are dollars, asking you how much you spent on something, the units of the variance are dollars squared. Okay, well, these squared measurements don't make much sense in the context of things, so they're not very useful. In order to measure the dispersion using the original units of the problem, which is much more useful, the statistician takes the square root of this answer we got above. So we're taking the variance and we're taking the square root of it in order to measure dispersion, and that's going to give us the standard deviation. And this is one that we use way more, because it is more useful because of its units. So the standard deviation is probably the most commonly used measure of dispersion. So if we find the standard deviation for the data from example 1, we can see here, we found the variance is 63.44. So sigma squared is 63.44. And in order to find the standard deviation, that's going to be sigma, because we're taking the square root of this. So we take the square root of both sides, gives us sigma, because that cancels out the squared, is equal to 8.75, and it's in movies, because it's talking about however many movies are streamed. Okay, so in order to find standard deviation, take the square root of the variance. Okay, so take the square root of the variance. So if we look at a different problem, if we look at the problem from before, finding the standard deviation from the following data set, I think this is the same as the one from practice problem 4. Yep. Okay, so if we find the mean, or we already found the mean as this 19.4. Okay, so if we take 11 minus 19.4, if we look over here, we can just copy these numbers down. Okay, so we have this 11 minus 19.4, 13 minus 19.4. We're just taking the number, subtracting the mean. So we get negative 8.4, negative 6.4, negative 4.4, 8.6, and then 10.6. Okay, and if we total all these together, we have 0 for those, again, because of the negative signs. And then if we square each number, so negative 8.4 squared is going to give us 70.56. If we square negative 6.4, we get 40.96. If we square negative 4.4, we get 19.36. If we square 8.6, we get 73.96. And then if we square 10.6, we get 112.36. Then if we add all those together, we get 317.2. Okay, so in order to find sigma squared, we're going to take all of these added together. So we'll take this 317.2 divided by the number of numbers we have. So we have 1, 2, 3, 4, 5. 5. That's going to give us about, let's type it in a calculator. Actually, I don't have it done yet. Okay, so we're going to do 317.2 divided by 5. We're going to get 63.44. Okay, so if we know that sigma squared is 63.44, in order to find sigma, small sigma, in order to find the standard deviation, we're just going to take the square root of both sides. So the square cancels out with the square root, giving us sigma. Square root of 63.44, you can type into a calculator, gives you 7.96. See if I can write 7.96. So again, you add all these numbers together, starting from the beginning. You're going to take the numbers and put them in the chart. Okay? Then you're going to subtract the mean from each of those numbers. Then you're going to square the answers you got here. So square this number, gives you this number. Add those together, divide by the number of numbers you have, take the square root of that answer. That's going to give you the standard deviation. Let me know if you guys have any questions about any of these problems, and I will help you the best I can. I hope you can work through the practice problems for these. Let me know if you have any issues with those as well, and just make a chart and go through just like I did one of these. Rewatch this if you have to. Rewatch me going through the problems or explaining how to do them. Have a great day, and I will see you guys later. Bye!